Okay, question 3. A user's computer has a central processing unit, CPU, that has a clock speed of 2 GHz. So he wants to change it to a CPU that has a clock speed of 3 GHz. State what is meant by clock speed. So a computer has an internal clock that dictates how fast your CPU is. So the clock speed determines how many operations a CPU can carry out in each second. So 3 GHz means that your CPU can do 3 billion things every second. But we need to really define what a thing is. So each clock tick, the CPU can do a fetch, a decode, and an execute. So every clock tick, that's what happens. So 3 billion times a second for this 3 GHz CPU, we do a fetch, a decode, and an execute each clock tick. So in our answer to what is meant by clock speed, so number of fetch, decode, executes per second, something like that. You can write it however you want, as long as that's what you're saying. Explain, so we need to give some justification or reasoning here, the effect this change will have on the performance of the CPU. So let's go back to the question. So they're starting off with 2 GHz, they're now going to 3 GHz. So they're essentially going to be able to do more fetch, decode, executes. You could say they're going to be able to do 1 billion more fetch, decode, executes every second. But for 2 marks, I think we should just be able to say more fetch, decode, executes per second. The computer will be faster. So I'm stating the obvious there, but they want 2 marks, and I'm not sure if just saying more fetch, decode, executes per second, even though that is the correct answer, will give me those 2 marks. We'll see the mark scheme in a second as well. Right, so talking about registers, in the last question, the CPU contains a memory address register, MAR. Describe the role of the MAR in the fetch, decode, execute cycle. And interestingly, they've actually given us the answer to part of the answer to the previous 2 questions in this question. Although you need to know what it is, that's quite helpful that they've actually put that there. Anyway, describe the role of the MAR in the fetch, decode, execute cycles. So the MAR, it tells us here it's the memory address register, so it's storing addresses. So what addresses is it storing? So let's just say stores addresses of let's say data for next instruction. So as the CPU is processing, the memory address register holds the address of the data for the next instruction, so where we need to get that from, or the address of where we want to write something to. Okay, so it's either the address of some data that we need, or the address of the location of where we want to write some data, or the address wish to store data. Okay, so we'll compare these with the mark scheme in a second. The CPU has a list of all the machine code commands it can process. State the name of this list of commands. So every CPU has its own set of instructions that it can follow, and we call that instruction set. Okay, let's have a quick review of the mark scheme. So we've got the maximum number of fetch, decode, execute cycles a CPU can perform in a second. So yeah, so we've got It's probably more than enough for 1 mark there, but that's 1 mark. So more fetch code executes per second, the computer will be faster. So increases the performance. So we've saying tasks can be performed faster. I think the computer will be faster. That's enough for that, because more fetch code execute cycles can be processed in a second. More fetch code executes per second. So I think we're good for 2 marks there. But yeah, I agree with what they've said. Tasks can be performed quicker or faster. So the task that the computer is currently doing, whether that's playing a game or working on a Word document. Okay, this one. So it stores addresses. That's required for 1 of the marks. So memory address register is the address register, and register store things, so it's storing addresses. Of the next instruction that we need, yeah, so we've got that, or where we're storing data, or where we wish to store data, or where we're going to write data. So yeah, that's okay. We're okay with that one. And then lastly, it's straightforward. That is the instruction set. Okay, right. Thank you for that. Let's. I'll stop this one and we'll move on to the next question.